Hello, algebra students. We're looking at 513, using factoring to solve problems. A couple of main points that you need to know, or helpful hints, is that now when you're factoring polynomials, the x squared may not drop out. We're used to that kind of canceling and that being an indicator that you're on the right path, but this time you know how to factor, so getting kind of all grown up in the algebra world, you might end up with the x squareds in your equation. And that means you might get multiple answers. And that's okay. That just means that there's more than one possible answer for a situation. You do want to continue to look for the GCF first. That is always true when you're factoring, so don't forget that. So our first example, the length of the rectangle is 8 centimeters greater than twice the width. And we're supposed to find the dimensions, the length and width, if the area is 42 centimeters squared. So you have a spot for drawing there. So we do want to make sure we're setting up. So we've got a rectangle, so you would want to sketch a rectangle. And it's saying the length of the rectangle is 8 centimeters greater than twice the width. So we have the width, and the length is 8 centimeters greater. So I know I'm adding 8 to twice the width. And there's my rectangle. So just looking for that setup. And then you know that your area of a rectangle is length times width. So area is equal to length times width. So we're going to set that up, and we also fill in what we know. So our area is 42 centimeters squared. And we have our length as 2w plus 8. And to find the area would be multiplying that times the width. So that's our setup. Then you go ahead and we work to solve. So on the right-hand side, I need to distribute my w. And I get 2w squared plus 8w. And then I would subtract 42 from both sides. And that's going to give me 0 is equal to 2w squared plus 8w minus 42. And that's where you're getting like everything to one side. And then you're going to factor. Now, of course, we look for our GCF first. And we have a greatest common factor of 2. And so I'm pulling out that common factor of 2. So from 2w squared, that would give us just the w squared. Plus, and from 8w, that would give us 4w. And dividing 42 by 2 would give us 21. So pulling out that GCF, then I want to factor into the binomials if I can. And the pattern would be that this is a minus, and so I know I have alternating signs, so I have my w, and I know I have alternating signs, so one is going to be plus and one is going to be minus, and I'm looking for factors of 21. That will give me a positive 4, and so of course I want my higher factor to be positive, so that's going to be the 7 and 3. Okay, and then my possibilities are all equal to 0. Well, 2 can't equal 0, so I don't have to worry about the 2. But I need to look at w plus 7 equaling 0. Or I have w minus 3 equaling 0. And so w is equal to negative 7, or w is equal to positive 3. Now, when we're looking at a rectangle's width, we can't have something be negative, so that this does not make sense in this situation, so we go with the 3. So you do have to keep in mind what would be real for the situations. And so then I would plug in, so I've got w is equal to 3, and so 2w plus 8 for finding my length is 2 times 3 plus 8, and so I get 6 plus 8, which is 14. And so now I have my answer. I have the dimensions of the rectangle are 3 centimeters by 14 centimeters. So in example 2, we have the sum of the squares of two consecutive odd integers is 290, and we're supposed to find the integers. So this kind of goes back to that setup of consecutive integers, evens and odds. And so we want to establish that setup. So x is going to be our first consecutive odd. And then our next consecutive odd, remember that even though it's odd, you're adding 2 because it would be plus 2 to get to the next odd number. And so that would be your second consecutive odd. And for the setup of the equation, it's telling us the sum of the squares of those two. So the sum means I am adding them, and the square of the first one would be x squared. The sum of the second one would be x plus 2 squared, and it's telling me that the sum of them is 290. So that would be the setup for that equation. Now I want to start to solve, so I've got to square my binomial. So I have x squared plus, and then x squared plus 2 is a perfect square. It would be a perfect square trinomial, so I get x squared plus, and then it would be like 2x plus 2x, so that's 4x plus 4. Now you could write that out and FOIL it if you're not sure how we're getting to that. And we get 290. Then we want to, simplify and get everything to one side. So we've got a couple steps to do here. We have like terms. So we have our like terms. So 2x squared plus 4x plus 4 is equal to 290. But then we want to get 0 on one side, so we're subtracting 290 from both sides. So we end up with 2x squared plus 4x minus 286 is equal to 0. Then, of course, we pull out our greatest common factor. We have a greatest common factor of 2. That's going to give us x squared plus 2x minus 143 is equal to 0. And we want to factor our trinomial into two binomials. Now, first term is x squared, so it's x times x. Because the second sign is minus, that means that our signs are alternating. And because the middle term is positive, it means our higher factor needs to be positive. So we're looking at factors of 143 that will get, or negative 143, that will give us a sum of 2. So of course, because this 2 is positive, we want the higher factor to be positive. And as I break that down, that's going to give me 13 and 11. Oh, I said that those needed to be alternating, but then I did not write them as alternating. There we go. And so that's got to be negative 11. Now, again, in this situation, obviously 2 cannot equal 0, so that gets eliminated. So I have x plus 13 is equal to 0, or x minus 11 is equal to 0. And so x is either negative 13 or x is equal to a positive 11. And those, because it's just consecutive odd integers, both those possibilities are true. And so we can either have, x is equal to 11, and then x plus 2 is equal 13, or x is equal to negative 13, and x plus 2 would equal negative 11. So we have those two different possibilities there. So in example 3, we get a parabolic shape, which is pretty common for factoring possibilities and solving equations with factoring. So we have a ball being thrown upward with initial speed of 14.7 meters per second. That's the rate, or r, in this coming formula. The height, h in meters m, and we don't really need this because the m does not apply in the formula, that the ball reaches t seconds, t for time, after being thrown, is given by the equation. So they're giving us the equation to follow, and we just have to plug in our unknowns. So just probably not necessary to do a sketch every time for this one, but just kind of picturing why you end up with more than one possibility for this here is you're throwing the ball up and it's going to come down, and that shape is parabolic. And so when we're looking for the ball to be 0.9 meters high, so we need to add in that question. Hold on a second. Okay, so we want to add that question in there. That should be in there, and it's like, when will the ball be 9.8 meters high? And the idea in this sketch is that because of when you throw the ball up and then it comes down, there's going to be two different spots where the ball will be at a certain height. And so we have a formula to figure that out. And we've got that formula. So we've got the height is equal to the rate, and in this case that is the meters per second, and times the time, and that is in seconds, minus 4.9 times the time in seconds squared. So just that is the formula, and you can see on the bottom of your sheet where it tells you the formula when it's not in meters but in feet. And so we plug in the information that we have, and our height is the 9.8 meters. I needed to provide that to you. Equals, and then our rate is the 14.7 from the story. And we're looking at when, and so that's our unknown. So the t is our unknown, minus 4.9 t squared. And, we just go through getting that 0 on a side. So we kind of want to get everything to one side. So I'm going to pull these terms over, and that's going to make my 4.9 t squared positive, which is nice. And then that will give me a negative 14.7 t, and plus 9.8 is equal to 0. And we want to pull out a common factor. And it's nice if you can make your coefficient 1, and so you'll see we can pull out a factor here of 4.9. So you always want to give that a try. That might not be like a first thought because you've got your decimals there. But if you can make that coefficient of the t squared term 1, it's a good idea to try. So we pull out 4.9, or divide every term by 4.9. We get t squared minus, and if you divide your 14.7t by 4.9, you'll find you get a nice integer answer of 3t plus, and then again, a nice integer answer of 2. So always giving it a try to kind of divide by that coefficient of the squared term. And then we have our 4.9 out front, and we want to factor our trinomial into two binomials. And so we've got t and t, and we've got this second piece being positive and the middle term being negative. So second piece being positive tells you the signs are matching, or the operations are matching, and because the middle term is negative, they must be matching minuses or negatives. And then we want factors of 2, positive 2, that are going to add up to negative 3. So that just gives us a 2 and a 1. So our possibilities then are that t minus 1 is equal to 0, or t minus 2 is equal to 0. And I'm running out of room here. So that gives us that t is equal to 1, or t is equal to 2. And there's those two possibilities there. So that means that the ball will be at 9.8 meters high at 1 second or at 2 seconds. Make sure you're bringing in your questions to your algebra teacher.